Okay, unfortunately here you have to use trial and error. Okay. You're going to have to go through all these, see if they're congruent. So ADC sucks, but you're going to have to do it. ADC didn't really say anything about those, okay? And EBC. Okay, here's how you can mark congruencies, okay? And also, you remember the ADC, that was congruent to something. And EBC, that was, those were congruent. And ADC at a right angle, right there. Because if that's right, that one's going to be right. That one's going to be right. Now, do you have an angle that's the same? That's the common. It'd be this one, C, okay? Well, that's ASA, so I believe that's why A is your thing. Okay, let's rehash that. Okay, kind of bumbled through it a little bit. So ADC. And then put any right angles or congruent sides. So that's a right angle. That's congruent to something. The other one they want to know. B, EBC. Okay, so that's a right angle as well. And that also had a congruent side marked. And then since we have the same letter, ASA. Okay, there we go. 45. What are the congruent corresponding parts? You got to have your sides and your angles. Okay, so the angle, so here's what you want to do. Okay. Name your sides, pick one triangle, so BC, CD, and BD. Now name your angles, so BCD on the first triangle, BDC, and DBC. And then to label your congruencies, all you have to look at is the congruency statement. So BC would go with FE, CD, it's ED, and then BD is FD. BCD, so BCD, it's FED. BDC, BDC, BFDE, and then DBC, DFE. Okay, 46. For quadrilaterals below, angle I is congruent to angle M. IJK is congruent to MJK. LKJ is congruent to NKJ, and angle L is congruent to angle N. Complete the congruency statement, okay? So LKJI, and then I'm going to list 4 letters out. Okay, they told me L and N were congruent, so N's got to be first. They also tell me I and M are congruent. Where is I? LKJI. Yeah, not E. It's I. So I is congruent to M, so we're going to put M right there. And they do share a common side right here, so I just put those letters in the same order. So K, J, and K, J, M. Okay, so you put your congruency angles in the same place, and then you see the quadrilaterals share a common side, so you just put those letters in the same formation. Are the triangles congruent? Okay. Everything's kind of been given to us right here. And the answer is yes, they are, because I have a side, two sides, and an angle, so yes. And I can justify that with the SAS postulate, because I got two sides and the angle between them. Remember, it can't be ASS, it's got to be SAS. Okay, are those congruent? Justify your answer. So let's look at what we have here. Okay, I see they got a common side, so reflexive property. 5 and 5, so let's mark those. 16 and 16. And even though I don't know anything about the angles, I have three sides, so yes with the SSS postulate. Side, side, side. Is there enough information to prove that true triangles are congruent? If yes, write the congruent statement, name the postulate you used. If no, not possible, tell other information. So we got to write the statement and the postulate. The postulate's better off first. Okay, so I got a side, another side, and the angle. So the angle's between the two sides, so I can use the SAS. Now, PQS, just put PQS. Okay, which angle is congruent then to Q? Well, it's just another Q, so the Q stays in the same place. Okay, P and R match up, and then the angle S kind of in the same place. Same formation, corresponding parts have to match up. Don't have to do 50. 51, explain how SSS, SAS, ASA, or AAS with the definition of congruent triangles prove that angle D is equivalent to angle B. Okay, so we got two sides that are congruent, side here, and an angle. Now there's an angle between the sides. It's not, it's the AS one, which isn't, but it's between them. So it is SAS. Then you're trying to prove D and B, and those are your corresponding parts, so then those would be congruents. Don't have to do the next ones. 54, 55. Are those congruent triangles by the hypotenuse leg? Remember what hypotenuse leg means. The hypotenuse has to be equal, and then another side. Any other side has to be equal. Okay, so if that's right, that's right. Now look opposite. There's your hypotenuse there. There's your hypotenuse there. They're both marked. So the hypotenuses are congruent. Now, do you have another side that's congruent? Yeah, right there, okay? So you got to name the legs that allow the use of the HL. So these are my hypotenuses. So what's the other side that's congruent? The one with 2, so that's DB. Okay, remember hypotenuse leg means the hypotenuse of opposite the right angle. Those need to have a mark. And there's got to be another mark. And the side with the other mark is DB. .56. SD is perpendicular to HT, means those two are right angles. And SH is congruent to ST, so SHST. And those also share a side, okay? We also know from the isosceles method that these two would also be congruent. Again, read that list, okay, on proofs. They had a common side. It was already marked. There's no vertical angles. It was isosceles, so I know those sides and those angles are congruent. Supplementary, no, okay? And also, if I have two sets of congruent angles, which I do, then the third side is also congruent. Double arc that. A lot of ways we can go with this, okay? So complete the proof. Given. Right angles, they already had those. Given. And it says reflexive property, we'll just write the common side. ds equals sd. It's congruent, I should say. And why are they congruent? Well, you could go over any number of statements right here. I mean, it doesn't have to be the hypotenuse leg theorem, to be honest with you. You can name them congruent using the ASA. Yep, the hypotenuses are congruent, the legs congruent. You could also use the HL theorem. Can't use side, side, side. Okay. You could use the SAS theorem because I got sides and the angles between them. So there's any number of ways you can go with that. Name a pair of triangles in the figure and state whether they're congruent by SSS, SAS, and you can kind of see the triangles. So you need they're overlapping. So, and also we have to label so NP and OM, or sorry, NP, wrong one, NP and OM, MN and PO. Okay, now separate them. So N, M, P, and after that's drawn, you need to still mark the congruencies. That's O, M, P, again, mark the congruencies. Now, do they share a similar side? Any two letters the same? Yeah, so that means that side is MP and MP. So that's SSS, okay? Can't be the HL, there's no right angle. You don't know anything about any of the angles. There's no way to find it, okay? So, number 58, complete the proof. CB is perpendicular to BD. So CD, CCD, and BD, those form a right angle. That's also a right angle. DE is perpendicular to EC. DE, EC, right there. You know that is. And then CB, side CB is congruent to DE. So CB and DE. Okay. So DBC is the one they want to know. So that one's right here. Whoops, sorry, I drew the wrong one. That's DBA. I need DBC. So DBC, and we knew that was a right angle, and that was congruent to something. Okay, it wants to know CED. Right there. know about that? I know we had a right angle here, and that was congruent. Okay. All right, do we have any common sides? Actually, I do. CD. CD. Any other common sides? Nope. What about common angles that were the same? Well, kind of. DCB and DCE, those aren't the same angle. Oh, I'm missing something here. That's about all I know. Now, I know you know two sides in an angle, but it's a right angle, so the hypotenuses both have 2, and then there's another leg that's congruent, so that's the HL theorem, okay? So to complete the proof, how do I know that CBD is congruent to DEC? So CBD, that's the right angle. DEC, that's the right angle. So I'm just going to put right angles right there. How do I know that CD is congruent to DCD? That's a reflexive property. And then we end up with the HL theorem. That's how we prove the triangles are congruent. Okay? The hypotenuse are congruent, and so is a leg. Okay, didn't have to do the next two. 61, separate and redraw ABC and CDA. So ABC's here. Don't really know why we have to separate them, but whatever. Okay, so A, B, C, and then CDA. Okay, common angles are common sides, okay? We'll look for a common angle, so I've got ABC, but there's no way I can get ABC in this because that's a D. CBA, there's no way I can get CBA. And then ACD, ACB, I should say it's a B right there. No angles are common. Do you have a common side? Just look for the same two letters. Yep, I think I do. Okay, AC, because AC is in both of them. That's why that's your answer, AC. Again, there's no common angles. Okay, if you just look at them, you know there's no common angles, but they do have a common side. You don't have to separate it. That's kind of stupid that they have you do that. Okay, AC. I would not separate those like I just did. I'd just look at it. Here's my two triangles. You can clearly see them. They don't overlap. And you know that none of the angles are the same because at angle A, they're different angles. C, they're different angles. They do have that one common side, though. 65. Is there enough information to prove that two triangles congruent by the AAS? So we need two angles and a side. If yes, write the congruency statement, explain. If no, write not possible, tell other information you need. So B and D are congruent. And we have these sides that are congruent. Okay, now I got to use the ASS method. Okay, the answer is not possible. Okay, because all I know is that we have an angle and a side. That doesn't do anything for me, so no. And you got to do the AAS. You got to know the theorem they want to use. So I need another angle, okay? Angle, side, that's possibility. So I'd have to prove that BAC is congruent to CAD. that would give me an angle, and a side. Okay, you're like, well, why can't you do this one? Okay, well, that would work too. Okay, you could also do that one as well. So BCA is congruent to ACD. Now it looks to me like if you knew that was a bisector, so you could use that. So AC is a bisector to, and you could either use it, it's an angle bisector DAB, or it could be a bisector to BCD. Either one of those is acceptable, okay, if you knew any one of those.